finally, we can start with our first keynote speaker. It's a pleasure for me to introduce Patrice Roulet. I'm going to give you some details about his bio. Based in Canada, Patrice heads Immervision engineering as well as contribute to IP growth and the adoption of Immervision 316 Panamorph technology by global corporations. Recently, he has led the miniaturization of the Panamorph 316 technology for smartphones, tablets, wearables, and IoT devices. Patrice has led the integration of 360 degrees imaging technology in consumer electronics, surveillance, automotive, aerospace, medical, and broadcast products. Back in 2000 in France, after completing his master's degree in image processing and computer graphics, Patrice joined to INRIA and contributed to their research in robotic surgery simulation field. In parallel, he co-founded Immervision, a company dedicated to 316 degrees optics and imaging technology, with its conviction that 316 technology could be applied everywhere. He contributed to the development of 316 degrees Panamorph optical and imaging technology. Beyond technology, Patrice believes that innovation is driven by human beings, partnership, and alliance. He was collaborated with a large ecosystem of partners in the optics industry like Fujifilm, CBC, Computer, Tacron, and Coleng, and in the silicon industry like Marvell, Intel, Qualcomm, Sony, Samsung, NXP, and Omnivision. In addition, Patrice is an avid surfer, international traveler, and always seeks to make new connections. So, Patrice, where you are? Okay. So, welcome to our conference.
So, thank you, Fernando, for the introduction. I appreciate a lot your support. Thank you, everyone. Good morning. It's really a pleasure for me to talk today in front of this audience. As Fernando said, I brief 360 technologies in 16 years with the strong conviction that 360 can be used everywhere. There is tons of application of this technology, including virtual reality and immersive technology. If you walked the CES show this year, you have seen multiple products allowing to display immersive environment, head-mounted display, for example, but also cameras, recording 360 environment as well. So I would say my first immersive experience starts in 1996, playing a famous video game, Doom, and for me it was a revelation. Using my computer, I was able to fear the dark in the middle of the day. I was able to feel like a hero in front of my desk. I was able to, what can I say? I was chased and hunted in the comfort of my couch. So starting from this, I said, okay, how we can recreate this experience and bring this at another level. I was not the only one. Even before that, people think about, okay, I can immerse myself in a 360 environment. But since 16 years from now, I push 360 technology and to startups and big corporations, explaining the use case, telling that it's the next medium and that everybody wants to share more than only a small window of their worlds. And it was quite a difficult path for me up to this event. So this person I would say, make in 5 minutes what I would take a century to me to explain. So thanks to Mark Zuckerberg, now I think the ecosystem become more mature and people understand better what is 360 technology. I have seen some 360 devices in this room this morning. But what is really key for 360, it starts first by a device to capture the content. And the quality of the device is really key to have a good experience. So since 16 years now, I was able to customize with my team the 360 capture for different applications, starting from surveillance first, then going to automotive, broadcast, and more recently, action cam, VR cam, and smartphone. And to do this, the lens technology is really key. Back in 2000, when we found Immervision, we were played with, I would say, existing lens at that time. The first panoramic lens invent was the catadioptric lens. So I don't know how much you are familiar with this type of lens, but it's basically just a spherical mirror in front of a camera. So there is two issues with this type of technology. The first one is the quality is not so good because you get the image from a mirror. And the second one is you have a large blind spot in the middle of the field of view, the black circle right in the middle, because of you have to hide the camera somewhere. The second panoramic lens technology invented by Nikon in the 60s is the fisheye. And back in 2000, we start playing with fisheye, start capturing image and videos, and start to assemble fisheye image together, and we noticed that the fisheye has a lot of issues. For example, when you look at an image coming from a fisheye, the quality in the center of the field of view is really good, but going toward the edge, there is a lot of diminution of image quality. And that's why we invent the panomorph technology. So the panomorph technology is a super wide angle lens, but really designed with the application in mind, and also considering the software processing behind the lens. So this technology brings a lot of benefits to create a 360 device. So the first one is what we call consumer on the same way. It really depends the result you want to achieve. So we take this in consideration inside the design to spread the pixel on the different way depending on the requirement. So that's the first level of flexibility that panomorph technology brings. The second one is what we call anamorphosis. So for example, the sensors are not square. There is more and more square sensor due to 360 capture now, but most of the sensors are not square. So to optimize the sensor coverage, we spread the image circle using optical element inside the lens to cover more pixels. So that's also another innovation of the panomorph technology. And the third one, it's, I would say, maybe the most important for this talk today is really the lens designed for 360 back-to-back application. So if you walk the show and you try different 360 device on the floor, you can see that, for example, panning around the 360 environment, you have some zone that with high resolution, with good quality, and then going toward the edge, the quality reduce, or toward the stitch area, the quality reduce, and then go up and reduce and go up. So this is not, it's not nice for 360 applications. So we use all the different features of the panomorph technology to create lenses really designed for those back-to-back applications. Means now, when you do the assembly of the two lenses back-to-back, you don't have this effect of good quality, bad quality at the stitch area, and good quality again. So when you put your head-mounted display on, you don't see any difference, no matter where you look at. So this is, for example, you have a graphic here where the pink zone is really the high quality, and the blue zone is the lower quality, and that's the behavior of the fisheye. So if you stick the two images together, going to in the stitch area, you can see a blurry zone. That is not the case with our design approach, the panomorph lens, where we smooth the image quality across the whole field of view. And to do so, we use the first technique I mentioned. So for example, the distortion control, where we can play with the distortion pattern to magnify some area of interest. So for example, on the right, you have the magnification toward the edge, where there is more pixel density on the edge than in the center. And on the left, you have the magnification right in the center. This type of magnification right in the center is more for endoscopy, when you want to mimic human eyes. The magnification toward the edge is more, for example, video surveillance application, where you put the camera on the ceiling and you want to enhance your zoom capability toward the edge of the field of view. The anamorphosis, so the other innovation of panomorph technology, so the way optically to spread the image circle to cover more pixels on the sensor. And this is really key, for example, when we design the lens for broadcast application. You want to leverage all the pixels of the full frame sensor. So in this case, you design the lens to cover as much pixel as you can on the existing sensor. And based on those different innovations, we have tons of design possibilities, and all the panomorph lens has different design pattern, and they are all different. So for example, you have a few lenses right now, and you can see the difference in size, in construction, and also in distortion pattern and image quality pattern. So all of those lenses are different and require different algorithm to process the image. So regarding the algorithms, it's an image processing algorithm to remove the distortion, flatten the image, and create different user experience. It could be like making just a flat image from the super wide angle image, or enabling pan and tilt and zoom navigation for different applications. So for example, you have few applications here of few processing for different applications. So the most famous now is, let's say, the VR experience. So starting from a 360 image, you process the image and then you create a surrounding environment effect in a head-mounted display. But you can go beyond that. So for example, on a smartphone, you can create super wide selfie, or also the selfie from your head to your feet, like the fashion selfie, or even conference application, putting your smartphone in the middle of the table and framing the different people around the table and stream that through Skype, WeChat, or any video conferencing application. And if you remember, so the lenses are all different with all are different distortion patterns. So we need to find a way to transport those parameters from the capture up to the display. And the most elegant way we found to do this is to make it as a part of the image. Instead of creating a specific file format or a new file standard for these specific contents, the goal is to leverage the existing video format or the existing image format and adding the necessary information directly inside the image. So the parameters of the lens, the position of the lens, all the calibration of the parameters of the device, and beyond. For example, in VR, we can add also the G-sensor information to, after that, stabilize the field of view. I will show you some demos of So for example here, it's an NHL game captured by a broadcast camera using our panomorph technology. And that's the raw image captured by the camera. And then, using the software processing, you can pan and tilt inside the contents. So you can, it's like giving a way to interact with the content in real time. So you can do this from your tablet, for example, in the same time than you see the game at the TV. So it's like giving you a unique viewpoint the sensation to be there. In this case, for example, you are right in the middle of the two teams. And there is no way, you cannot buy this seat. So it's really a way to enjoy new experience. Another application is what we call, let's say, consumer immersive lifestyle camera. So in this case, the person is on the roof of the car and pan the camera left and right. What is interesting in this example is the camera embed the G sensor, the inertial motion unit. So no matter the movement, and you can still see the movement on the small video here, no matter the movement of the camera, the field of view remains stable. And this is enabled by the inertial motion unit. And if you remember the markers inside the image, so that is the raw content. So each image is marked with all the parameters from the camera, including the orientation of the camera, and then the dewarping software focus on the right orientation according to the user interaction. So that's another example of what the technology enables. It's really key for VR, because if you capture 360 content and you put this content in a head-mounted display, either you use a tripod or you have to use this type of technology to focus the field of view. You don't want the user to become dizzy by the movement of the capture. So that's the way to enable 360 user-generated content. Another example is, in this case, is the back-to-back. So there is two lens stick back-to-back together, and we can pan and tilt the complete environment. I lose my mouse. Here we go. So, and it's the same. It's the same here. The raw content include all the parameters, the two image circle plus all the parameters required to do the stitching live in real time on the mobile phone or in the head-mounted display. So let's talk a little bit more about the future. So you have seen maybe at the CES multiple 360 cameras. And those cameras are very exciting. I enjoy to play with that, but I guess that's to bring the adoption to another level. It has to be embedded inside the smartphone. You carry your smartphone all day long, and having this type of technology directly in your pocket will allow you to capture 360 content and directly stream those content through the social media platform. So giving to the users the sensation to be there, to enjoy what you are enjoying, or to feel what you feel in real time. So that's why we did a lot of effort to miniaturize the technology to bring the lens at the size that it can be embedded inside the smartphone to create 360 back-to-back camera directly inside. And beside the lens miniaturization, we also worked a lot on the software processing to enable this type of user experience inside the smartphone. And to do so, we have to consider that in such a device, there is a limited heat budget, there is a limited power budget. So we have to optimize the process and separate the different processing regarding the different components inside the smartphone. So the idea here is really to enable the capture device to capture the raw content, plus marking this content with all the information using the regular capture pipeline of the device, and to leverage the viewing device capabilities to stitch and dewarp the content in real time. So it's like It's an innovative approach because it's like splitting the process in two parts. One is the capture and one is the viewing, so it can be done by two separate devices. And that's an elegant way to balance the processing load. So from the capture side, there is a lot of processing that has to be developed and done to make this happen. And for example, company that the chipset vendors are now developing this type of technology like dual ISP to capture the two frames together and be able to manage the exposure, the white balance, and all the different processing in real time for the two cameras and make the content homogeneous from left and right. This is a exciting challenge because when you have a camera facing the light and the other camera on the back facing the dark area of the scene, you really have to manage the ISP processing to make the full 360 environment equal across the whole field of view. So that is existing, and it's already implemented in flagship application processor for smartphone. And also the capability to dewarp and do the assembly of the image. So now most of smartphones embed powerful GPU, allowing this type of processing directly inside the device, smartphone or head-mounted display. So, and the main benefits of this approach is really that enable low-power device to capture 360 content, to spread the technology to the large amount of device, and enabling live streaming of your moments directly to social media platform and video sharing platform. On our side, we are a technology company, so we don't do product. We bring the technology to the OEMs making product. So either the lens technology or the image processing technology, we bring this technology to them and we help them to make their 360 product, their 360 application. And we work with the complete software ecosystem to make this, from the capture up to the display, to make this compatible. I mean, the capture device has to be compatible with the display device to share the content smoothly. So I just take two examples of recent project we work on this year. So it's already from the super small camera, an immersive lifestyle camera that you can carry all the time with you and with the super small panomorph lens inside to capture 360 content, up to the super big 360 camera for broadcast. So on our side, we work with those companies providing the lens technology and the imaging technology to make them realize, to help them to make those products. And if you walk the show, if you have walked the show, you have seen that there is multiple 360 products, multiple 360 application, way to capture the content, way to display the content. And I'm really happy to see that myself because I believe in that since 16 years. What is missing now is a standardization of from the capture up to the display. And that's where the big corporation now has to take the lead and standardize this way to capture immersive content and display it. And on our side, we are happy to provide the tools to help in that. Thank you very much for your time. I really appreciate your attention. And if you have any question, don't hesitate. Yes.
Thank you very much for sharing your 16 years of pioneering VR experience. Yeah. I would like to ask you, based on your technology, have you ever thought about the impact on youth development linking the vision to the brain. Has there been any hindrance or improvement based on the usage of this technology? Thank you.
What I would answer to this is panomorph technology is the best technology to mimic human eyes. And either for vision application or even for artificial intelligence. Now you can see a lot of neural networks and deep learning algorithms ingesting images that are small windows of the world. What would happen if we give to the brains or artificial brain the capability to see like we see? What would be the future? What would create in terms of future, the future of here, if we give them the real sense, the real vision sense that we have? We are all gears.
Okay. Hi. Okay. I enjoyed the talk very much. You mentioned the importance of standardization, and I agree that it's very important. But in terms of the standardized representation of the 360 content, my understanding is that the MPEG committee is working on an effort to have some sort of specification for 360-degree video, I think by the end of this year. I was wondering, are you involved in that effort or aware of it? Can you give us any update on that?
I cannot mention too much about this. I know that there is different initiative in terms of standardization. I haven't seen yet something coming out. If you look at, for example, the social media platform right now, they all ingest what we call equirectangular or planispheric projection. And from the background from the broadcast industry, for example, this equirectangular or planispheric projection require a lot of computing to process the image and also transform the pixels. So I think the industry is eager to have a standard that be able to share the native raw content, not a converted content. So if MPEG has this type of initiative, I think it would be great. And we would be happy to participate with that.
Any other questions?
Yeah, one more. Okay.
Yeah.
Okay, thank you. Well, thank you for the opportunity to ask my second question.
No problem.
What is the cost prediction based on this technology? Seems to me you're introducing that to the smartphone. How do you think the cost base is going to be affected right now versus maybe a few years down the road? Thank you.
So you mean the cost of the device itself? Okay. Okay. On our side, we do a lot of effort to keep the cost down of the technology. So when we design the lens, we design the lens in collaboration with major lens manufacturer in each industry. So for example, for industrial or surveillance, we work with Fujifilm or Tamron in Japan. And for consumer, we work with, for example, Colen would supply Samsung and LG for smartphone lens. So we design the lens with the cost in mind to keep I would say, the cost of the lens as a high-end smartphone lens, existing smartphone lens. So I don't see too much impact on the cost for the future smartphone product with the 360 capability.
Okay, I think we have no more time for questions because we need to start the regular session. So thank you, Patrice, for your very interesting introduction of your presentation.
My pleasure.
And thank you very much, everybody, for coming. And before leaving the room, I want to highlight some issues. But first, I want to give you a small present.
Thank you very much. Thank you all.